Okay, so today we're looking at 9.8, which is the last section of chapter 9. And what it's really doing is we're putting everything we've learned in chapter 9 together. And 9.8 is on factoring completely. So this will involve factoring out monomials. It might use difference of squares. It might just use our standard factoring. It might use more difficult factoring with an X box. It's basically just compiling everything we've learned in chapter 9 and wrapping it up into one section. So we're going to start with being asked to factor something similar to what we've already done. We have 27x squared minus 75. Well, it's a binomial, and it's not a difference of squares the way it looks right now. So the first question we need to ask for all of these is, what monomial can I factor out? What do 27x squared and 75 have in common? Well, 75 doesn't have any x attached to it, so really the question is, what do 27 and 75 have in common? And the answer here is they're both divisible by 3. So we can factor out a 3, and then we need to ask what we're left with. 3 times what gets you 27x squared? Well, that's just 9x squared. 3 times what gets you 75? That's 25. So now we need to ask, is this completely factored? And the answer here is no. We have 9x squared minus 25, and this is a difference of two perfect squares. This is what we saw in 9.7. So 9x squared minus 25 is 3x minus 5 times 3x plus 5. Now we can't factor any more of these pieces out anymore, so we are done. This is factored completely at this point. So using that same idea, let's try this one on the bottom. We have 45x to the fourth minus 20x squared. First thing we need to ask is, what common monomial can we factor out? Well, let's start with just looking at 45 and 20. What number goes into both of those? What's the greatest common factor? The answer here would be 5. So we can definitely factor out a 5. Now we have x to the fourth and x squared, so we actually can factor out another x squared. X squared goes into x to the fourth, and x squared factors into x squared. So now what are we left with on the inside? 5 times what gets you 45? The answer there is 9. X squared times what gets you x to the fourth? Well, x squared. We factored out 5x squared from negative 20x squared, so we're left with just 4. Now, similar to what we had above, 9x squared minus 4, 9x squared is a perfect square, which we actually already just saw, and 4 is a perfect square. So we can use the difference of squares method again to factor 9x squared minus 4 into 3x minus 2 times 3x plus 2. And remember, the order of these things doesn't matter. You could have 5x squared times 3x plus 2 times 3x minus 2. That's totally fine. Multiplication is commutative. But at this point, this entire expression is factored completely. So let's try a few more of these. If you want, at any point, feel free to pause the video and try these on your own. I might recommend it. First, what you're going to do is factor out a monomial, and then you're going to factor by any means after that. So go ahead and pause the video if you'd like. Try A, B, or if you want to follow along, that's okay too. So here what we're going to do first is factor out a 4x, because 4 goes into 4, 20, and 24, and x would go into x cubed, x squared, and x. So we're going to start there. What are we left with now? Well, just an x squared. Then we have a 5x, and then a 6. So now we're not going to use difference of squares, but we are just going to use our typical factoring method. What two numbers multiply to 6 but add to 5? The answer there would be 3 and 2. So you have 4x times x plus 3 times x plus 2. And now this expression is factored completely. Look at the bottom example, very, very similar to the one above. We're going to factor out a 5x, because 5 goes into 5, 5 goes into negative 25, 5 goes into 30, and x goes into x cubed, x squared, and x. So we're left with just x squared minus 5x minus 6. This problem is actually eerily similar to the one above. What two numbers multiply to -6 but add to -5? The answer there would be -6 and +1. -6 times 1 is -6. -6 plus 1 is -5. So at this point, this expression is completely factored. Okay, let's look at something new for 9.8, but hopefully not completely confusing. We can actually factor out a common binomial. So what this means is we don't necessarily just need to factor out a monomial, which we've done most of the time, but we can factor out a binomial. So what this looks like is if you have something that's 4x times x minus 3 plus 5 times x minus 3 again, instead of distributing and simplifying, you can actually just factor out an x minus 3 because both pieces contain x minus 3. So we're going to have x minus 3 and write it on the outside, and then what we're left with is just 4x plus 5. This would work the same way, just going to show you over here. If you had 4xy plus 5y, I'm just replacing x minus 3 with y. You could simplify that as y times 4x plus 5. But in our case, y is just x minus 3. It's just something being multiplied to both terms. So another similar example, we have 2y squared times y minus 5 minus 3 times 5 minus y. Well, y minus 5 and 5 minus y are not the same. So what we can do to make them look the same is multiply this 5 minus y by a -1. But what that would do is change this to a +3. So let's just look at what I mean. Everything on the left is going to stay the same. And instead of saying this is, if we were to distribute, we would have -15 plus 3y. We're just going to change this to plus 3 times y minus 5. That's a legal move. We're just factoring out a -1 here, because if you look back at the distributing, you would have -15, which is what we'd have here, and a positive 3y, which is what we would have here. So it's a little tricky, but it is a perfectly legal move to factor out a -1 from here. And now what we can do is we can factor out our common binomial again. We have y minus 5 and y minus 5. So we'll write our y minus 5 on the outside, and we're left on the inside with 2y squared plus 3. And 2y squared plus 3 won't factor at all, so we can just leave our answer like this.